In this lesson, we are going to talk about our residuals. So when we examine residuals, we already kind of know what it's about. We're saying, what's the difference between our predicted and actual values? And obviously our goal of the least squared regression line is to minimize those residuals. But they also have a couple of other purposes. The one purpose is that it's going to reveal patterns in our data that maybe we can't see just by looking at the data. And they also help us to determine if we should actually use linear regression or not. So here's an example again of the scatter plot for emperor penguins. This gives me the duration in minutes of a dive and the heart rate of that dive. And if I find the least squared regression line, I have my dive heart rate hat, so the predicted dive heart rate equals 96.9 minus 5.47 multiplied by duration. It gives me a correlation coefficient of negative 0.8456, which is fairly strong. However, if I look at it, it kind of looks like there's more of a curve going on, and that concerns me. So one way to check to see if I should be doing linear correlation here is to find the residual plot. Now what I'm looking for in a residual plot is I want scatter. I want all kinds of scatter. I don't want to see any direction. I don't want to see any shape, no bends, no patterns, no outliers. I just want to see a bunch of dots. This is the residual scatter plot for my penguin data. And looking at it, I can see that there seems to be, and quite often, I'm going to go ahead and draw this in here, you'll see a straight line. They're supposed to be straight. You'll see a straight line right at 0. But really what I want to see is the same thing on each side of that. I want to see that it's just scattered. But what I see instead is that this one looks like it's sort of funneling off. And that's not good. We don't want to see this. We want to see a scatter plot that's just scattered all over the place. So because there's a narrowing of the residual plot, we might need to straighten it, or we might not be able to do linear regression at all. Now we'll talk about how to straighten it in a later lesson, but that's what I'm looking for in a residual plot. When we examine residuals, again, it might also be helpful to look at specific residuals. So I was looking at the overall pattern of, say, calories in different types of cereals. We've got some differences up here and some differences down here. The high residuals are just right fruit and nut, muesli, raisins, dates, and almonds, Mucilix crispy blend, Nutrigrain almond raisin. Those residuals are high, and therefore it might be helpful to sort of separate those out and look at them separately, because the residual is much higher than we would imagine. Now we're going to examine some residuals on our TI-84. So there's two different things that you can do on your calculator when it comes to residuals. The first is to make your residual plot. So if we're going to use our Atlanta travel data that we used previously that's already in my calculator, I'm going to go to my second and y equals, which is my stat plot, and notice that all of my stat plots are turned off except for number 1. And in number 1, I've chosen scatter plot, which is what I wanted. My X list is L1, which was my previous X's. And then for Y list, I need to choose residual. So to find that, I go to second and list, and then choose residual, which in my case is the 7th one down. I don't care what the mark is or what the color is, but then if I zoom 9, I now have my scatter plot. So looking at that scatter plot, I'm a little bit concerned that most of the data is over here, so it may be possible that the linear regression equation is not the best way to go. We'll talk more about that when we talk about the ladder of powers. The other thing I can do when it comes to residuals is to actually examine specific residuals. So here was my original data that I was looking at, and I want to know what each individual residual is. So to do that, I would go to Stat and then Edit, and I'm going to arrow up to L3, and then I'm going to do the same thing. I'm going to go to Second and List, and I'm going to choose the residuals, and then I'm going to press Enter. And notice what has happened now is they have calculated all of the residuals for me. So you might be asking, why do we care? What's important about a residual? Here's how I would compare this. Remember that residuals are found by taking y minus y hat. Y hat would be the value that we have found using our regression equation. Y would be all of these values right here. That's what Y is. So if I'm looking at, for instance, negative 28.57, which would be looking at my 222. So looking at Boston, what it's basically telling me is that 222 minus what my model predicts gives me negative 28.57. Again, why is that important? That tells me it costs more to go to Boston than it probably should based on the rest of my data. So I would be looking at those values that are very, very small or very, very large so that I could see what the biggest differences are. If you have a residual that is crazy far away from everything else, it could be that that is an outlier and that I should then actually create my scatter plot and exclude that point and find out a model that includes all of the data except for that point.